So we can see that our load balancer got created and our public IP address associated with that load balancer. Let's go into the load balancer. Now, we've only created a load balancer, but we haven't hooked it up with anything. There is no servers, there's no backend pools, virtual machines that are waiting to receive traffic. We haven't set up the health probes in order to determine if those servers are healthy. So what I'm going to do is I'm going to create 3 virtual machines and an availability set. And then we're going to show you how to add that availability set to this. Again, it's a basic level, basic SKU load balancer. So we're restricted to only virtual machines, individual virtual machines or virtual machines and availability set. So I'm going to pause this and create 3 virtual machines and availability set. All right, so I've created 3 new virtual machines in an availability set. Let's add this to the load balancer. So we go under backend pools and we say add. We have to give it a name, so AZ load balancer backend pool IPv4, and it's a matter of associating with one of 3 things. Now I can associate it with an availability set, which is what we're going to do in this case. We can associate it with a single virtual machine, which then we'd have to do it multiple times for the load balancer to have multiple virtual machines. Or we can associate it with the virtual machine scale set. Okay. Remember, we saw in the basic load balancer, you can only choose one of these options. So the question is, what availability set? Now, the availability set must exist within the same region as your load balancer. It makes sense because if you think of your load balancer as running on a server within East US2 region, you want your virtual machines also in East US2 region. Don't have your virtual machines in Europe while your load balancers in the United States. That's going to be a very high latency, slow thing to do, and obviously Microsoft doesn't even allow that. So the availability set must exist within East US2. And we're not done yet. We still have to add the virtual machines inside of this. Okay, so we've got our availability set, and now we can choose our virtual machines. I've created AZ VM1, VM2, and VM3. There's one network interface card on each of those, and so we're going to choose the one network interface card. We're going to go to the second virtual machine, choose that network interface card, and the third virtual machine, and the third network interface card. Okay. So now we have, we have to click that, but let's do that. All right, now we have 3 virtual machines that were in an availability set that are going to be part of our backend pool. Let's click OK. I guess it doesn't like that, so let's delete that. Click OK. That's going to take a few minutes for this backend pool to be constructed. Now while that's running, we can see that it's some deployments are going on here. We'll let that run. Let's talk about health probes. So we're going to go on to the health probes section. Now remember, we said that load balancers, they're pretty dumb machines, except they do have the ability to check on the health of the virtual machines in their backend pool. And then if they detect one is not responding within a reasonable time, then it will kick that machine out of the virtual backend pool. Okay, so let's create a health probe. Got to give it a name like usual. So let's call it health. It's IPv4. Now the health probe can either check on the status of a port. So in this case, it's just going to ping port 80 over the TCP protocol, and then every 5 seconds in this setting, every 5 seconds it's going to touch port 80, and if it fails to open port 80 twice consecutively, so it takes about 10 seconds of failures before it says, unhealthy health probe has been triggered. Okay, so this is within 10 seconds this will detect that port 80 is no longer opening. Another popular way to do that is based on HTTP probe. So even if port 80 is responding, that doesn't mean that your application is healthy. Okay, so you may want to pull in the web page that's at the root, the home page, if you will, and then if it's able to get a 200 success code from the home page, then that's considered a healthy probe, or 2 consecutive failures to be unhealthy. A lot of people will create a standalone web page like health.htm or probe.htm, where you can make this part of your application, and so that you're not pulling down your home page, which might be a fairly heavy page and might cause your application some performance concerns if you're hitting that home page every 5 seconds. And so creating a standalone page that is simply for the health probe to check on the status might be a smart alternative. Okay, so you'll see that there's pros and cons to checking just the port, or checking the application, or having some kind of proxy page that is designed to fail if your application isn't up. Now be careful, obviously with an HTML page, that could very well continue working while your home page is not responding, or while your .NET application is not responding. So there's some strategy in terms of choosing your healthiness. Let's change it to the TCP probe, so that it doesn't matter what application we have running, as long as port 80 is responding, then we are considered healthy. Actually, yeah, considered healthy. I haven't enabled 443 for those servers. Okay. So now we're creating a health probe that is simply it's simply going to be happy if port 80 is responding. Now for these virtual machines that I've created, I actually haven't logged into them to set up IIS, to set up web servers on them. I haven't added the web server role. So I imagine port 80 is going to fail. So while we're waiting for this backend pool to finish updating, while we're waiting for the health probe to be created, we know that these servers are not going to respond on port 80 because I haven't set them up yet. Okay, so I would expect all 3 servers within 10 seconds of them being live to basically be kicked out of the pool because they are not responding on port 80. All right, we have our server set up. We have our health probes. Now let's set up the load balancing rules, because as it stands right now, this load balancer isn't configured. It doesn't have any rules, and so we're going to have to create one. So at least one set of load balancing rules. So new rules. So it's an IPv4 load balancer. We've got our IP address, which is load balancer front end. We are accepting traffic from the public over port 80. We are sending traffic to the other VMs over port 80. So there is the possibility of what's called NAT, or net address translation, network address translation. So we could have port 8080 set up on the VMs, and then the load balancer handles the public port 80. That would be a security setup, but we're going to leave it as a pass-through where port 80 comes in and port 80 goes out. We've got our pool, which is the only pool we've set up, the 3 virtual machines. We've got our health probe, which is the only health probe that we have. We do not support sessions, and so each client that comes in is going to be put to a random virtual machine. We're not going to then send the same client to the same virtual machine. We could, of course, say the same IP address always goes to the same virtual machine if we wanted to enforce have sessions, but in this case we won't. And basically we can ignore this idle, we can ignore this IP address and say OK. And this is basically what is required between the backend pools, the health probes, and the load balancing rule in order to get this load balancing working. Okay. So once this rule gets deployed, then we're going to have a working load balancer.